Welcome to solverfy.
All right, two things we have to do here. We have to come up with a formula for the nth term, and these have to be in terms of Fibonacci numbers, so f of something, where f is a Fibonacci term. Then we have to prove it works for all real numbers. So let's go ahead and just start plugging some numbers in. So if I plug in 1 for n, that means, also we are given that the first term is 1. Okay, so now when I plug in 1 for n, I get 1 plus 1. We're finding the second term. So I might as well finish this off and say is 1 over 1 plus the first term. Well, we know the first term. The first term is 1. So this is 1 plus 1 over 1, 1 over 2, 1/2. Okay, let's do the next one. That would be plugging in a 2 for n, which really means we're actually finding the third term. It's kind of how it works when you're plugging in a 2, you're not finding the second term. Anyway, 1 plus 1 plus, and remember, this is a to the n, and we're saying n is 2. And I'm going to go ahead and say a to the 2, that's this 1/2 here. So let's go ahead and plug that in right now. 1/2. And I'll go ahead and do a couple steps. This one's a little bit more complex. 1 over, 1 plus 1/2 is 1.5, or 3 over 2. And if you're dividing by a fraction, that's the same thing as multiplying 1 times the reciprocal of this. Flip numerator and denominator. 2 over 3. Well, that's 2/3. Hopefully you're starting to see the pattern. I'll do one more, and then I'll just write in a couple of the next terms. But I think it doesn't really stand out, maybe until we do one more. So we get, this is going to be A3, or the third term. There's that third term, so I'm going to go ahead and plug in a 2/3. All right, that becomes 1 over 1 plus 2/3 is 5/3. And remember, that's the same thing as saying multiply 1, the numerator, by the reciprocal, 3/5. And so I'm going to line these up. I'm going to write 1 as the fraction 1 over 1, and then 1/2, 2/3, and then 3/5 is where it kind of stands out to me, because before then there's a couple other fractions that could have been impossible, but check it out. It is the Fibonacci sequence. 1, 1, 2, 3. You better believe the next one's 5. And this one is just 1 ahead, so there's a 1 that it skips. So it's 1, 2, 3, 5, 8. And it'll continue on and on. And so I'm going to say the nth term, well, that is the Fibonacci sequence on top for our numerator. And then it's almost the same on bottom, except because they skipped this one, they're 1 ahead. Or it's the n plus 1 term of the Fibonacci sequence. I'm going to say that is our a to the n. But that's only one step. Now we have to prove it is true. So to prove it's true, let's go ahead and use mathematical induction. I'm going to go to a new page. So here's what we're trying to prove is true. F of n over f of n plus 1 is the nth term. All right, and so we're going to use induction to kind of say, okay, well, what if I plug in a 1? And if I plug in a 1, that means it should end up being the first term over the, 1 plus 1 is 2. It should be the first term over the second term, which is 1 over 1. Let's rewind and look back to the previous page and see if that's true. Yes, it is. The first term is 1 over 1. So we got that. Next, we're going to go ahead and do the kth term. And we're going to assume this to be true, where we just plug in k for n. We're going to assume that this is true for the kth term, that it'll be the kth term of the Fibonacci sequence over the k plus 1 term of the Fibonacci sequence. And so, knowing that, let's try to do the k plus 1 term, and then we will be done. To do the k plus 1 term, not surprisingly, we're going to get k plus 1 over, well, the k plus 1 term of the Fibonacci sequence is a mouthful, over the k plus 1 plus 1, k plus 2 term of the Fibonacci sequence. Okay, and so to do this, I'm going to go ahead and write, I know the k plus 1th term is the same as saying, well, let's rewind 2 terms and say, okay, that's k minus 1 plus k, or the k minus 1th term plus the kth term. Same thing over here, except if I go back 2, I'm just at the kth term. If I go back 1, I am at the k plus 1 term. And using some logic here, we can actually kind of say that this proof is essentially done. And here's why. Is because this is what we assumed to be true over here. And so what would we do to get to the next term? Well, we would just add the previous term to each of these. And that would absolutely get us to the k plus 2. That would absolutely get us to the k plus 1. This, by definition, is proving itself because we assumed this to be true. So how do we get to k plus 1? We just add the previous term. How do we get to k plus 2? We add the previous term. So this does indeed prove, assuming this to be true, that our formula does work for that nth term.